Hello, everybody. This is Dr. Sanchez, and I am providing a few comments on exercise 3, comparing karyotypes, for which is found on page 43 in chapter 2. So comparing karyotypes is important for humans. We do it all the time, particularly when there is a question regarding possible genetic disorders such as trisomies. Trisomies are when an individual has 3 copies of a particular chromosome rather than the usual 2 copies. And the reason why karyotypes are created is to rule out these types of extras, right? Simply because some of these extras can cause significant health complications for individuals. So, but that is up to parents to determine whether they feel they need to screen, if they perhaps have a family history of a particular kind of genetic difference, and then they will make those decisions whether to carry a pregnancy to full term or to terminate, depending upon their own particular values and beliefs. In anthropology, we use karyotypes not only for examining living people and their potential offspring, but we also use them for comparing humans to other kinds of animals. And of course, we're most interested in comparing humans to other primates to see the kinds of chromosomal and genetic variations that we can observe between us and our primate cousins. So if you haven't yet completed exercise 3, I'm going to ask you to stop here and do exercise 3 and see what you are able to find out, what you're able to conclude. But if you've completed exercise 3 and you found it a little bit challenging, then keep on listening, because I'm going to talk about what is challenging about this particular exercise. And right now I'm going to share an image. And this image is a comparison of human chromosomes and primate chromosomes, in particular a chimpanzee chromosome, chimpanzee karyotype, I should say, right? So in the green up above, we have the different chromosomes, and of course we are only looking at half the complement for chromosomes 1 through 22. But remember, for chromosome 23, which these are the sex chromosomes, then there is a possibility of a difference, right? So that an individual can have 2 X chromosomes, or they can have an X and a Y chromosome, and those are the general inherited chromosomes, although certainly not the only possibilities. And this is another incidence where we can find trisomy on the 23rd chromosomes. So it is certainly possible for an individual to inherit 3 copies of the X chromosome, or they can inherit 1 X and 2 Y chromosomes. There are lots of variations that happen here, and it's also entirely possible for an individual to only have 1 X chromosome, and those differences can result in some genetic disorders, but generally speaking, people carry extra chromosomes with no real challenge or major difference. It's just an extra, right? But on some of these, then again, these having an extra can lead to multiple different kinds of genetic disorders. But anyway, back to comparing a human karyotype to a chimpanzee karyotype. And here we see that if they look very much alike, and if we just do, a general count, right? So both of them have, of course, chromosome 23. And for both examples here, we have a human male and a chimpanzee male. The X chromosome, of course, is much larger than the Y chromosome. And then we have going all the way from 22 up to 3. Those all look very, very similar in number. And both human and chimpanzee have chromosome 1. But where we find a big difference is with chromosome 2. In chromosome 2, for the great apes, this includes chimpanzees, gorillas, and orangutans, they actually have 2 chromosomes here. So what we would call 2A and 2B. Whereas humans only have a single mega chromosome, the number 2 chromosome. What we believe happened was that somewhere after the split between us and the other great apes, that the 2 chromosomes 2A and 2B, they became fused. And so this resulted in humans ending up having a total of 46 chromosomes, that is 23 pairs, whereas great apes, they have 48 chromosomes in total, or 24 pairs. This is one of the significant differences on a genetic level between humans and the great apes. It's very interesting to think about how this might have happened. And if you're interested, I recommend that you look it up, because I don't really know when, how, or what for. So I recommend you taking a look at it. But what does this mean in terms of interactions between humans and chimpanzees? And we do know from looking at other species that disparate species can mate and produce offspring. So, for example, humans have been breeding mules for a very long time, and mules, of course, are the offspring of horses and donkeys, with the offspring resulting in mules. Now, mules themselves are infertile. They cannot replicate. And this is because donkeys and horses do not have the same number of chromosomes. And so this causes the resultant mule to be just genetically off, so that they can't reproduce on their own. They're a hybrid. They're not an actual species. So if you want a mule, you always have to mate a horse and a donkey to get a mule, because you can't get one by mating 2 mules. If you get a female mule and a male mule, they can go through the reproductive act, but it will never result in a pregnancy. So what would happen if we were to cross human with ape? Now, that may seem to be just an outrageous question, but let me tell you, in science, some people have wondered this for a long time. And apparently, sometime in the past, in the early 20th century, an experiment was actually conducted to hybridize human with chimpanzee. Would it be possible? Well, if we take the horse and donkey example, well, a human and chimpanzee cross is possible, and it would result in a hybrid. And in all likelihood, that hybrid would be sterile, just like a mule is sterile. Is there anybody out there today trying to cross humans and chimpanzees? Well, if they are, they're probably breaking any number of regulations, laws, and medical ethics. We do not do this kind of experimentation anymore. And for the experiment that was conducted in the early 20th century, it did result in a live offspring, which was destroyed because the scientist probably came to his right mind and realized what a real ethical problem this was going to be. So if you completed exercise 3 and you had a hard time figuring out what the correct answer was for number 2, describe 2 things that differ between the karyotypes. Well, one of those differences is going to be for animal 1, there are actually 2 distinct chromosome 2. So there's a 2A and a 2B. And then for animal 2, this is a human karyotype. We know this because humans have 23 pairs. We see 23 pairs there. And we have that extra long chromosome number 2, the result of a fusion. So then we can say, okay, which is which? So animal 1 is some type of an ape, and I'm just going to go ahead and tell you that it is indeed a chimpanzee. If you turn the page to page 44, it tells you one of these is a chimpanzee. And so that's one of the major differences between on a genetic level and chimpanzees and other apes. So I hope this was, helpful. You can go back and take a look at exercise 3 so that you can see that difference. And of course, there are numerous other differences between the 2 karyotypes. Another that pops out to me right away is comparing the 23rd set, which are the sex chromosomes, that the Y chromosome in humans is larger than it is for chimpanzees. What that might mean, I don't know. But there, of course, are, when you get down to the genetic level, there are a number of differences, yet we are very, very similar between the 2 species. So again, I hope this was helpful, and I will end here. Take care, and talk with you soon.